All right, hi everybody. So we're gonna go through a couple of questions today over horizontal projectile motion, kind of give you that full culmination of practice questions. So you'll have the practice question with relative motion, and then you have these practice questions with horizontal projectile motion. So let's say that if the first one, Bubba wants to know how fast he can pitch. I'll zoom in a little bit. Okay, so wants to know how fast he can pitch. So he has a baseball and he throws it out horizontally. And to kind of figure this out, we're going to say he's on a 4-meter height, throws the ball travels out, hits the ground, and there's a distance, delta x of 25 meters. Okay, our goal is to figure out how fast was the baseball thrown. Okay, so let's get it going with our x and our y. Okay, and start listing out kind of our guaranteed known. So the y-axis, a guaranteed known, acceleration negative 9.8 meters per second squared, and the v initial y is 0, and in the x-axis we have acceleration being 0, and our v initial in the x is our question mark. Okay. These are my guaranteed knowns, and let's add in our other stuff. So delta y is equal to negative 4 meters, and delta x is 25 meters. Okay? So, have all this information. Okay? Remember, our only equation for the x-axis is the delta x equals the initial x t. It's the only equation in the x-axis. Y-axis, we have all three. All three kinematic equations are viable, okay? But there's only one equation in the x-axis. So, well, we know our delta x is 25. Trying to find our v initial x times our goal. So, using this information on the y-axis, let's solve for time. And basically, the only equation we have in the y-axis to solve for time right now is this one. Okay, it's our bread and butter equation. So negative 4 is equal to negative, or say 1/2, negative 9.8 t squared. So solve it out, negative 4 divided by negative 4.9. Okay, so it takes time about basically almost a second, 0.904 roughly seconds to hit the ground. So now we can use our x-axis. So I have 25 is equal to v initial t okay, and so Bubba throws a baseball at roughly 27.67 meters per second. That's a mighty fine pitch. Okay. I have no idea what that is in miles per hour. You can Google that if you want. So there's the first question. Noise. Second question. Okay. Second question. Let's say we'll make this an impact velocity question in a way. So, ball's kicked, goes out, boom. Oopsie, sorry. goes up, boom. Okay. So, let's say this. Okay, we know the impact velocity is 13 meters per second at an angle of 25 degrees. All right? So what we're saying is this object coming down, boop, boop, coming at the ground, hits it, and then the angle at which it hits the ground at is 25 degrees. I'll zoom in a bit, sorry for that. Okay. What is the height and how far did go? Question mark. My question marks are terrible. So we want to know what is the height and how far the object goes. So this one, it's actually going to be a we're gonna go from end to beginning. We're gonna work our way backwards. Okay. So x and y, because why not? Let's get this going. Acceleration negative 9.8 meters per second. The initial y is 0. Acceleration is 0. Okay, that's kind of all I can write is just that bit of information. So, okay, not too much. But what we can do is use this end stuff and kind of extrapolate backwards. If you think about it. Boop, boop. This is 13. This is 25 degrees. If we use this information, we can find our v final x and our v final y. We can find those two pieces of information. So this is where we're going to use our SOHCAHTOA. So x ends up being our cosine, so I have cosine of 25 is equal to v final x over 13. V final x is equal to, I'm just going to kind of do this off screen, make sure we're in degree mode, not radian. Oops, these actually turn my calculator off. So 13 cosine 25.78 meters per second. Y-axis is going to be our sine. I'm just going to write this one out because it's the same exact thing, but we're using sine. And we get negative 5.49 meters per second. When you solve this out in your calculator, it's going to give you a positive 5.49. It's negative because the object is heading vertically downward. Okay, actually, that's really useful information because if we come back here, I now actually can say my v initial x is equal to my v final x is equal to 11.78. Woohoo! And with my v final y is negative 5.78 meters per second, or 5.49, my apologies, negative 5.49. I can now actually solve for some stuff because I have enough information, especially in the y-axis, to solve for a few things. So for the y-axis, I can say v final y squared is v initial y squared plus 2a delta y. I can solve for my delta y. So I have negative 5.49 squared is equal to 2 times negative 9.8 times delta y. Okay? Squared divided by 2 times. Okay, So remember, this object is starting to height up. So I just specifically include the positive sign for this, because remember, in your calculator, it's going to give you negative. So make that positive. So we have a height. Okay. Well, our goal is still to find the distance, how far it went. So we have a height, so we got to find a distance x. Well, we got to actually find a time. So using this information, let's solve for time using our delta y equation. Delta y is equal to v initial yt plus 1/2 at squared. Sorry, I probably should have done this on another page, but I committed to this page. 1/2 negative 9.8 t squared. Okay. I'm not going to go through the steps of this one. I'm just going to say time is what it is. I'm so sorry. Kind of have to move this around. I apologize. This got real messy real quick. Not really messy, just really tight. Okay, so divide by 9 square root. So time is 0.56 seconds. Sorry, there we go. Got a little glare. 0.56 seconds is the time based off of this equation to there. So now I have a time. We'll pop back over here, and I'll say delta x is equal to v initial x t. So I have delta x is equal to 11.78 times 0.56. Delta x is equal to times 11.78, roughly 6.6 meters. Boom. All right. So that one's going, working our way backwards. Hopefully that helps you out. If you have any questions about that, please let me know. Have a good one.